In today's video, we are going to take a quick look at factoring. You've already done factoring in the past. I'm going to go through some of the basic principles just to kind of give you a refresher. If you need more help with factoring, you are going to need to get the help because we are going to work on factoring we're going to use factoring to solve, to graph, to write equations. You're going to see factoring coming up quite often throughout the entire course, not just in this unit. So to begin with, we're going to start with the most basic way to factor, and that's by factoring out a common monomial. It's finding what's common amongst all of your terms and pulling it out. So what can be multiplied back in to get what you have? So in other words, what can you factor out? It's the opposite of what can you multiply in. So initially here in the first problem, 2a squared plus 3a, both of those terms have an a in it. Just an a. There's no number that they're evenly divisible by. A is the only thing that both sides are divisible by. So I factor out an a. So a times what gives you 2a squared? 2a. Plus a times what gives you 3a? That's 3. Now, after you factor, you should be able to check them by expanding back in. Multiply through that a. Just do a quick check. You're not going to do this very often. But if you're ever questioning if you did something correct, distribute it through. It's 2a squared plus 3a. That's what we started with. So my solution is the part that's in the red. That is factored. The next example, I'm going to look for the same thing. In this example, they both have the same variable, x, and they also both have a number. Now this is 4x squared y minus 16x to the fifth. So I have to figure out, well, how many x's do they both share? Think of it as saying 4x, x, y, minus 16x, x, 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 x. So they both share 2 x's. So I'm going to pull out an x squared. And then instead of 16, I could rewrite that as 4 times 4, specifically because I know there's a 4 there. So then they both share a 4 as well, so I can factor out a 4x squared. So then what's left? In the first term, there's just a y, minus in the second term, there's a 4 and 3 x's, which is x cubed. So therefore, my final answer for this factor, it's neatly written, is 4x squared times the quantity y minus 4x cubed. Now, you don't have to go through all of this work. You may just be able to see, okay, there's an x squared in each of these, factor that out. There's a multiple. Here a 4, factor that out. What's left over? Again, do that quick check, expand it through, make sure that you're correct. So that's the easiest way to factor is with a common monomial. This next example is going to set us up for splitting the middle term. It's just kind of a precursor to it. So this is kind of an odd way to look at a problem. You're not usually going to see them in this form. You may. But it's kind of that same process. Look at each of them individually and factor out a common monomial. So in this first binomial set, they both share an x. And then what's left is x plus 3. Now again, my goal is factoring. Plus, in the second one, they both share a 4. Well, what's left? X plus 3. Now if you notice, they are both attached to the exact same thing. The x is attached to x plus 3, and the 4 is attached to x plus 3. Now let's instead think of this as 2z plus 4z. We all learned early on simplifying, combining like terms. These are like terms because they both have the exact same variable, z. So then I do what the coefficients say. 2 plus 4 gives me 6z. Same process here. They both have the exact same thing attached to them. So you can think of these as like terms. They're not exactly, but it kind of follows that process. So then, because those are the same, I do what the coefficients say. X plus 4. And then that's attached to x plus 3. Like the 6 was attached to z by multiplication. The x plus 4 is attached to the x plus 3 by multiplication. I can only do this because it's an x plus 3 in both of them. If one was an x plus 3 and the other was an x minus 3, couldn't do it. So this is going to be our process as to where we're going to go with splitting the middle term. But this is factored. Factors are items attached simply by multiplication. So now we're going to split the middle term. In order to split the middle term, we have to figure out how I can, as it says, split this middle term so that after I do that, I get the exact same things attached. So there's a process we have to go through. I specifically set it up because these were the two items that made it work. So now I have to split this middle term up, that negative 11x, into two different items so that when I split them apart, it works out nicely. So in order to do that, we have to look at what's called a product and a sum. Splitting the middle term works for everything that's in ax squared plus bx plus c form. That's how splitting the middle term always works when it's three items. Now, it could be an ax to the fourth plus a bx to the squared plus c. It could be in quadratic nature. But there's just going to be some times it works and there's going to be some times it doesn't work. But in order to go through this, what we're going to look at is we're going to look at what's called the product and the sum. And hopefully you are familiar with this. The product is the a value times the c value. So it's the coefficient of x squared, which is my 2, times my c value, which is my constant, that 5. So therefore, my product is going to be 10 for this problem. And then I have to find my sum. My sum is the b value. And my b value, it's the coefficient, is negative 11. So I have to figure out what two numbers multiply to give me 12 and add to give me negative 11. Now this one hopefully is a little bit more straightforward. Product, the only way to get 10 is 1 and 10 and 2 and 5, or the negatives, both of them being negative. But you have to be careful because our sum has to be negative as well. What you may wish to do if you start to get to one that's a little bit more difficult, write out the products. 1 and 10, 2 and 5. Because I know my sum is negative, I know that there has to be some kind of negative taking place. Because my product's positive, they both have to be negative. Gives you a nice visual to see which ones work. So, product, these both fit. Sum, which of these add together to give you negative 11? The negative 1 and negative 10. So that's how you go through and figure out what numbers are going to physically make this process work. So now I rewrite this. 2x squared plus a negative 1x plus a negative 10x plus 5. The process I went through with the product and sum was to figure out what two numbers work when I split the middle term. What I should be able to do is I should take those two values there and add them up, and it has to give me negative 11x. Otherwise, I change the problem and it doesn't work. So do a quick check. Negative 1 plus negative 10. Yep, that's negative 11. This is where you will catch your mistakes when you make them. It's just doing that quick addition in your head. I do like to do plus negatives for each of them because we're going to have to factor out negative numbers sometimes along the way, and we have to be careful. You can put the negative 10x first and the negative 1x second. It's totally up to you. So now, I have to get it back to look like where it was before. So what I had in the last term is they were grouped with parentheses. I randomly grouped two of things together. There's nothing mathematically wrong with it. I'm not changing the value of anything. Addition can be done in any order we want. That's why I do all pluses. And then if it's a negative number, I put the negative in there. Because if it's a subtraction, I can't just randomly group them together. So that's my little tip for you. Put plus signs in between there. I have to have a plus in the middle. That's probably the biggest feature. So now I look at the first binomial here. I look within this region. What do both of them share? An x. What's left? 2x plus a negative 1 minus 1, however you want to write that. My next here, I drop down this plus sign. That's important. There's a plus there. What can I factor out of here? The second one, we don't have leading coefficients as negatives. So factor out a negative if that first one is a negative, and specifically there's also a 5 in there. So I'm going to factor out a negative 5. So negative 5 times what gives you negative 10x? That's 2x. Negative 5 times what gives you 5? That's minus 1. If you notice, these both have 2x minus 1s. They have to, or you did something wrong. If they are not exactly the same, something went wrong along the way. So now, just like before, we add our like pieces. Since those are the same, I do what the coefficients say. X plus negative 5, which is the same thing as x minus 5. And I attach that like part, 2x minus 1. So you just completed a problem by splitting the middle term. Again, ax squared plus bx plus c form. This works every single time. The majority of the time, you're going to see my work is going to be showing this way as well, unless I physically do it in my head. There's nothing wrong with factoring in your head. If you can do guess and check in your head, keeping in mind the product in some pieces, some of you are really good at it. Don't feel like you have to drop that. However, keep in mind, you're going to get some ugly problems, and just doing it in your head might be a little bit difficult for you. Splitting the middle term works every single time. There's one more way that you can look at this ax squared plus bx plus c form, and that's what's called the box method. Some of you were taught this probably at the intermediate level. It's just another way of organizing the data. It's still exactly the same though. The process we go through is completely the same. We still have to do the product and sum. Product is a times c, so product is 10, sum is negative 11. What two numbers work? Negative 10, negative 1. I just did this problem. So those are the two numbers that work. So that's splitting up my middle term. Then we make a box. The first top left box is my first term, 2x squared. My bottom right box is my constant 5. The middle terms that I'm breaking apart, the negative 10x and the negative 1x. It has an x. It has to have an x. The middle term had an x. Put those here. Again, it doesn't matter which order you do it in, totally your choice. Now, I have to factor out across my boxes. So I factor out here. Going horizontally, I can factor out 2 and an x. So what's left? 2x times x gives me 2x squared. 2x times what gives you negative 10x? 2x times negative 5. And going down, what can I factor out of the bottom? Again, you don't want that leading coefficient to be negative, so I'm going to factor out a negative 1. So negative 1 times x gives you negative 1x. And negative 1 times negative 5 gives you a positive 5. So it works. So therefore my factors, x minus 5 and 2x minus 1. Because these both have minus signs, you knew what operation to put in there. If there isn't, it's a plus sign. So again, exact same process, just a different spot once you get to this feature here. It's the only difference between the two. Feel free to use whichever method you want. In solutions, you will see this method. However, some of you, this might be the way to go. Please keep in mind that whichever method you use, first step, you have to factor out a common monomial. If you use the box method, you will not always have that correct otherwise. So first step, factor out a common monomial. Second step, try to split the middle term and go from there.